Hey everybody, it's Calvin Hendryx-Parker here for Gestalt IT, and I'm really excited today. I am talking with Josh Hilliker from Intel. Josh, why don't you go ahead and give yourself a quick introduction?
You bet. Hi, Calvin. I'm Josh Hilliker with Intel. I'm a cloud solutions architect in our DCG SMG area. My focus is on intelligent data centers, telemetry, and all that good stuff. And if you want to, if anybody wants to follow me or have a conversation with me, please look me up on LinkedIn. It's Josh.Hilliker.
That's awesome. So that was a lot of acronyms all in one go, which is probably pretty standard for what we're talking about. But today we're going to be talking about the modern autonomous data center and some other acronyms that go along with that. But when I think of Intel, I'm kind of thinking of various hardware, processors, CPUs, things like that. Now we're going to be talking more about the cloud, not specifically data center. What is Intel? Why is Intel matter in your cloud or in the cloud?
No, absolutely. Yeah. I mean, when you traditionally you think of Intel, you think of manufacturing company, right? You think of processors. And
Right.
then, we extend that to all the different products, whether it's the NICs, whether it's the FPGA cards, whether it's Optane SSD, whether it's persistent memory module, right? You just continue down the list of hardware. But we're so much more than that from a software standpoint, from the optimizations we made based on top of it, and all of the what I call is like those enabling building blocks for the cloud,
Right.
right? So when we start to dig into any of the cloud solutions, you start to see like, oh, that's where Intel matters. They can help me with this. And I know we're going to talk a little bit more about that, of course, in the modern autonomous data center.
Well, I was gonna say now that we're getting kind of digging into the modern autonomous data center and talking about all these places where Intel actually does have its chips and its silicon, buried all throughout your infrastructure. Where are customers seeing the biggest inefficiencies in their data centers? Why are we sitting here talking about this right now?
A couple different vectors that I believe matter in this inefficiency conversation. One is around power, right? So having the right density, the right footprint, being able to get, pack as much in a rack as you can. So we call that increasing density, right? And knowing what your current power levels are and being able to react based on the situations or the utilization of those nodes. The other aspect is around just operational efficiency. So, how can I get as much of utilization out of that node as possible that is reasonable? When I say reasonable, meaning I don't want to put so much workload on that my latency critical workload starts to get diminished, and then I have latency problems, right? But I don't want to have just latency critical on a machine and only use 20% of the utilization. So it's around that kind of that operational efficiency. The other key vector is around reliability. So how do I keep what I've got going? Right, a very very rudimentary way of saying it, but it's like, how do I know? How do I know when I'm about to get a problem on an SSD? How do I know when I'm about to get a problem on a DIMM, PSU, fans? Right. I mean, I could extend that conversation to spindle drives, but thankfully that we're seeing a lot of the spindle being the worst problem is shifting away as we reduce the amount of spindles in the environment, right?
Which
Because
I
of
agree with.
mechanical problems.
It's
I
nuts.
Yes, I agree, and so I don't have to worry about am I hearing clanking, right? Like what's happening, right, with the disk. But having that reliability is so key.
Yeah, but it sounds like you need a lot of data to do that. I mean, it sounds like there's a lot of telemetry data coming off of here. We're gonna need to grab all that data and then do something with it. We need to figure out how we can understand those concepts you just outlined to then make decisions. So how do we kind of filter or wade through all that noise to pull out the pieces we need? And are there tools that are helping us do that?
When you look at, I like to say is I don't like doing recreational telemetry. Um, yes, I started doing that in the late '90s when I was at Intel, where it was like I want everything,
Hmm.
and then you start filling up. And back then it was like I'd fill up my SQL database and be like, I need more storage space. I need more. And it's like, well, what are you doing with that? I don't know. I'm collecting everything. So the first part is what telemetry will do what for what, right? So being able to map that of if I'm looking for bottlenecks, am I using our top level microarchitecture method, right? And what am I looking for? If I'm looking for efficiency of the system, I need to look at a couple of key basic like memory utilization, CPU utilization, CPI to kind of see what's happening on the box to be able to start going down that path. So first thing is collecting the right stuff. And we do at Intel, I believe we've done a great job of explaining here are the type of metrics you look for. And I posted actually some of those on my GitHub. on my external GitHub, where I have kind of, here are the metrics that matter, I call, that are the things you look for and what you want to collect, and at what frequency or interval you want to collect it at. So that's like kind of the collecting what's important and using it. The second part is around tools. And yes, we've created, like I said, a list of what metrics that matters. We've also provided the computation formulas of how to get to a metric that you could do something with. So like raw counters are cool. I mean, I it's like 1 point whatever to the power of e. I mean, everything, you look at it, you're like, oh, it's a great number. Well, what does that mean? What do I do with it? Not until it says, hey, this is your cycles per instruction metric, and you really want to be around a 2 or lower, when you start to say, oh, now I know how to react based on that.
Yeah, but I feel like we're not autonomous yet. Like, how are we going to
No.
see,
Yeah.
technologies like machine learning coming into the data center and helping us augment the human decision process? And even could we dip into? I know you've talked a little bit about telemetry aware scheduling and our actual applications. Can they now become aware of these availability resources for usage?
Absolutely. So we'll start with kind of AI in the DC
Yeah.
for the DC, or what we call AI for operations, right? It's like, okay, AI is great for, learning the pictures and doing, textual behavior and NLP, natural language processing. But it's like, what about me? What about the DC? And it's like, and so absolutely, we're like, we are on that path where in the power space, we could do dynamic power management at the rack or at the DC level and let it run on its own. Okay. You also, what we saw, and I think Google posted this, gosh, maybe like a year or 2 years ago, where they're doing, they're doing automatic thermal controls within their data center. So data center is managing it on its own for the thermal aspect of it. And that is absolutely kind of, to me, that's AI for ops. That's AI for my data center. As we continue that forward, it's like, first is getting the information, knowing what the thresholds and behavior are, and then what's my action, right? And then doing that loop without any, some people call it the closed loop automation, but it's really that autonomous nature. And with scheduling, we are on that path. So the telemetry aware scheduler is all about knowing what's happening in real time. So there's this part of scheduling with, like a Kubernetes or Docker, where it's,
Mm-hmm.
I need this requirement to land on this box, right? Like I need this amount of CPU, memory, and storage, right? I need that. And you can say, I need that, place the workload that has hardware like this. We've extended that model to now say, we have provided the Intel hardware features and made that available to the scheduler. So now the scheduler can say, oh, now I've got, 8 more attributes I can add to a workload. So now you could be smart about where you place it, which is step one. The second part is grabbing the telemetry back on how the system's really operating. And as soon as you start to see detection on that, to start shifting the workload around. And that's kind of that autonomous, finally, for the application standpoint
Yeah.
of saying, okay, where is it, where does it need to go? And then what's really happening on the node level, or that, within that cluster, and then shift it accordingly without anybody touching anything.
Yeah. So then, how do you take this technology and translate that into? I've got it in my private data center right now, but what if I want to start moving into the public cloud? AWS or GCP. Can I take advantage of these technologies there as well?
Oh, absolutely. So whether when we talk about telemetry, what's great is at the AWS conference, this that just
Yeah,
happened.
it's going on right
There's
now.
a It's going on right now. There was an AWS announcement about telemetry and about some of their connectors they prepared, and that is just another huge, to me, another huge flag that, hey, telemetry matters. You could do it in both locations, specifically from an Intel standpoint with things called PMUs, and I can operate PMUs and in the cloud, public cloud, and private cloud to get that same type of rich telemetry to make decisions off of.
Yeah,
And I
that's
mean, and
awesome.
and I know, just if you continue on for just 1 second around what we see in the Google space with GKE and Anthos and the cloud, I can move it seamlessly from on-prem to cloud without any issues, and that is truly that's getting us further down that autonomous path,
Yeah.
right?
Well, it sounds like you
Of
take advantage of maybe hardware capabilities that may be in a public cloud that you don't have in your data center.
Absolutely. I mean,
Awesome.
think about you have a workload that needs AVX 512, and I
Yeah.
can now say, hey, I need this. Well, they have it in the cloud. I'm going to shift over to the cloud and use that there.
That's awesome. That's exactly what we need. All right, Josh, I want to thank you so much for being with us here today. And we look forward to all the further advancements. It sounds like you can track those things through your GitHub, the Intel open source pages, and any other links you want to provide.
That sounds great. Calvin, thanks for having me.